Welcome to our event 2 of Mass and Energy in Tecmilenio Campus Villahermosa. Our team is Abdiel, Luis, Arturo, and Angélica, and we are going to talk about the topics of the Module 2, geometry of a motion with constant acceleration and its causes. Starting with Topic 6, one-dimension motion with constant acceleration. Well, in this topic, first we have the free fall, which is basically uh, any object dropping from up, so it goes down because of the force of gravity. Uh, then we have the vertical throw direct downwards. Uh, in this one, we assume that an object is launched vertically down, so the initial velocity is negative because it points to the ground. The initial position is zero, so the final velocity and position will also be increasing negatively. And last, we have the vertical throw direct upwards. In this, any object is launched vertically up, so the initial velocity is positive, and it will be decreasing until it reaches zero. And then it will fall until it reaches the initial position where it could stop or fall down. It depends of the position of the on the initial position. And that's all of the topic 6. Topic 7, two-dimensional motion with constant acceleration. Here we have first the projectile motion, which is a projectile is like a object particle that moves near the Earth's surface only because of its weight. And the first data given to us about a projectile is that its initial velocity next to launch angle, which is greater than 0 degrees but less than 90. Then we have the horizontal throw, which is basically is the half of the parabolic motion. It is an special scenario where an object that is in horizontal surface travels horizontally on it, and when it reaches the end of this surface, it will start to fall, but moving horizontally. And for last, we have the uniform circle motion, where the angular displacement of a body shows us its amount of rotation. Um, Basically, any 360 degrees turn is known as a revolution.
Topic 8. Newton's laws of motions. First law, also known as the inertia law, states that in the absence of external forces, a body at a racing state will always remain this way, or if it is in a state of motion at constant speed, it will continue in this state. Second law, also known as the law of motion, states that the acceleration that a body acquires is directly proportional to the resultant applied force and inversely proportional to its mass. Third law, also known as the action-reaction law, states that for every action force there is a corresponding reaction force, which is equal in magnitude but with an opposite direction.
I'm going to explain the topic number 9, graphical, qualitative, and quantitative description of forces. Common forces in the problems of Newtonian mechanics. A force is a physical quantity vector that describes the interaction between two objects. They may be in contact or separated. Weight. The distance force of a mass with a gravitational field produced by the Earth, also called gravitational force, always go vertically downwards in the direction of the center of the Earth. Normal force. Contact force due to contact between an object with a plane or a surface, with a direction that is perpendicular to the contact surface. Tension in a rope. Force manifested in every point of a rope due to the application of two equal forces on each end of the rope. Free body diagram. Free body diagram is a diagram showing the forces acting on an object, emitted from the origin of the Cartesian plane, the origin representing the object or in question. Friction. These are two kinds of friction: static friction without relative motion and kinetic friction with relative motions. Facts to consider. The static friction coefficient is always greater than the kinetic coefficient, so the static friction is always greater than the kinetic friction. In conclusion, in this topic we analyze in detail the types of forces that occur in different physical systems that are more common in Newtonian mechanics, which must be analyzed using free body diagrams, showing the forces acting on an object.
Topic 10. Applications of Newton's laws. Inertial law. The first law of motion refutes the Aristotelian idea that a body can only keep moving if a force is applied to it. Fundamental law of dynamics. This law is responsible for quantifying the concept of force. The acceleration that a body acquires is proportional to the net force applied to it. The constant of proportionality is the mass of the body. Understanding force as the cause of the change in motion and the proportionality between the printed force and the change in the speed of a body is the essence of the second law. Third law, action and reaction. Newton's third law states that whenever an object exerts a force on a second object, it exerts a force of equal magnitude and direction, but in the opposite direction on the first. To every action, there is always an equal reaction, but in the opposite direction. In any interaction, there are a pair of action and reaction forces located in the same direction with the same magnitude and opposite directions. All these topics conclude our evidence 2. Thank you for watching.